In this problem, we want to sketch a graph of the polar equation r equals 1 minus 2 cosine of theta. Before we do that, we have to sketch the graph of y equals 1 minus 2 cosine of x. Let's analyze the given equation. The given equation can be written as y equals minus 2 cosine of x plus 1 . This one is added to the function y equals minus 2 cosine of x, so that means there is a vertical shift up 1 unit. These two indicate the vertical stretch. And this negative sign indicate there is a vertical reflection. This vertical stretch affects the amplitude. So amplitude becomes 2. By looking at this part, we can determine the period. Nothing appears in front of x, so this function's period is the same as original function cosine function's period, so that becomes 2 pi. Before we determine maximum and minimum of the new function, we want to discuss the maximum and minimum of the function y equals minus 2 cosine of x. Maximum of y equals minus 2 cosine of x is 2, and minimum of y equals minus 2 cosine of x is minus 2. By using this information, we can determine the maximum and minimum of y equals minus 2 cosine of x plus 1. Maximum is 3 and minimum is minus 1. Those come from by adding 1 to maximum and minimum to the maximum and minimum of y equals minus 2 cosine of x. So 2 plus 1 gives us 3, and minus 2 plus 1 gives us minus 1. And vertical shift up by 1 unit also implies previous x-axis. Shift up 1 unit, and it becomes y equals 1. If you combine all the information, then you will get this graph. The period of this function is the same as the period of cosine function, so benchmarks are the same as the benchmarks in the cosine function. So it goes like 0, pi over 2, pi, 3 pi over 2, and 2 pi. There was a vertical shift up by 1 unit, so x-axis in y equals minus 2 cosine of x will be shifted up 1 unit, and it becomes y equals 1. The maximum was 3 and minimum was minus 1. Because of the vertical reflection, the function starts at the minimum value and follow the wave pattern. In this graph, when you interpret the geometric meaning, when you draw the polar equation, if the function is located below y-axis, then that indicates the negative distance. And we have to clarify where the graph is negative distance by calculating digit point between 0 and 2 pi. To identify the x-intercept, let's solve the equation 1 minus 2 cosine of x equals 0. We will consider the interval 0 to 2 pi. Firstly, we will solve for cosine of x. So let's move 2 cosine of x to the right by adding 2 cosine of x on both sides. Then on the left side, we have 1, and on the right side, we have 2 cosine of x. We divide by 2 on both sides, then we get cosine of x equals 1 over 2. The reference angle, which is involved to that, is pi over 3. We want to identify the angle whose cosine value becomes 1/2 among the angle from 0 to 2 pi. Cosine value is positive, so the angle will be located in the first or fourth quadrant, because in the first and fourth quadrant, x values are positive, so cosine values are positive. This angle, reference angles are pi/3. For this angle, we interpret 2 pi as 6 pi/3, and we think about the difference between two angles, then we get 5 pi/3. So solution for the equation in the interval 0 to 2 pi is pi/3 and 5 pi/3. So this one is pi/3 and this one is 5 pi/3. This determines the region where the function value becomes negative between 0 and 2 pi. You can determine DH by looking at the graph. In the interval form, this can be written as 0 to pi/3 with open parenthesis, or 5 pi/3 to 2 pi with open parenthesis. To graph the polar equation, I embedded polar coordinate in the rectangular coordinate. To graph it, we have to refer to this graph. What you have to keep in mind is y is an oriented distance. So if y is less than 0, then the point will be located on the other direction of the terminal side of the angle. For example, if we consider the point between 0 and pi/3, then in this region, y values are negative. If you consider the polar coordinate, then we are thinking about these angles. However, the oriented distance is negative. That means you have to locate the angle between pi and 4 pi over 3. So angle varies this way, but in the opposite direction, the angle varies in this way. In this graph, we see that when angle is 0, the distance is -1. Angle is 0 is positive x-axis, but we are thinking about the negative distance, so we are considering the negative x-axis. And the distance between the origin and the point will be 1, so we start at this point. And we vary the angle in this way. And when it becomes pi over 3, it eventually becomes 0. So it'll pass the origin. What happens in between will be the distance between the origin and that point will become smaller and smaller. The only way that can happen will be when the graph looks like this. This is the direction. Let's say that part is 1 and this is region 1. And in region 2, when angle varies between pi over 3 to pi over 2. So we are thinking about these angles. So angle varies in this way. The distance started from 0 and it'll increase and then it becomes 1 when the angle becomes pi over 2. So when you follow through these angles, the distance will gradually increase and then eventually becomes 1. So the shape will look like this. If we consider the region between pi over 2 to pi, then the distance will start from 1 and then it'll increase and eventually become 3. It will follow the angle direction. So we are thinking about these angles and we are going this way. So when it becomes pi, the distance becomes 3 and it gradually increases the distance from the origin. So the graph will look like this. Region 4 is between pi and 3 pi over 2. When the angles are between pi to 3 pi over 2, the angle varies in this direction. The distance was 3 when the angle was pi. However, it decreases and eventually becomes 1. So when angle becomes 3 pi over 2, we have to mark at this point. And then we will follow this way. Let's consider the region between 3 pi over 2 and 5 pi over 3. Then we are thinking about these angles. The angle varies counterclockwise. This is region 5. The initial distance is 1 at the angle 3 pi over 2. So we start from here, and the distance between the origin and the point will gradually decrease and eventually become 0. So we go this way because our angle varies this way. We go this way until it reaches 0. So that is region 5. Between the angle 5 pi over 3 and 2 pi, function values are negative. So instead of we varies the angle between 5 pi over 3 to 2 pi, we have to go the other direction. If you go the other direction, then 5 pi over 3 will correspond to 2 pi over 3. And when we go this way, we go this way, starting from 2 pi over 3, and we move toward pi. When the angle was 5 pi over 3, the distance was 0. And when it becomes 2 pi, the distance became negative 1. So we start from here and we go the other direction of 2 pi. So we go pi direction, and then we hit this point. So we follow this graph. So this is the region 6. That's how you draw the graph of r equals 1 minus 2 cosine of theta. This is an example of the Limacon. General equation of Limacon will be r equals a plus or minus b sine of theta, or r equals a plus or minus b cosine of theta. In the first example, we learned about the special case of Limacon. When these values are the same, those are called cardioid.